friends, welcome back to my YouTube channel. So in the previous lecture we have discussed about that is oxidation number method for balancing your redox reaction one, but it is in the acidic medium. Now in today's lecture we are going to learn in the basic medium how we can balance the redox reaction one. So let us start with the steps one. Again in the similar manner I am going to take one example and simultaneously you will going to learn about the each steps. The step number first, write the unbalanced net equation of a redox reaction. Balance the equation for all atom except hydrogen and oxygen. Assign the oxidation number to all atom in both reactant and the product one. Okay, let us consider a simple example for this one, that is MnO4 minus aqueous plus Br minus aqueous gives MnO2 solid plus PrO3 minus aqueous. Let us consider the step number first. Again write this unbalanced equation and assign the oxidation number for it one. So again write down MnO4 minus aqueous plus Br minus aqueous gives MnO2 plus BrO3 minus aqueous one. So as we know that both these sides, the Mns are same and the bromines are same, and we cannot balance the oxygen atom in the step first one. So this reaction we have to simply now assign the oxidation number for each one. Now let us assign the oxidation number for the each atom. Okay, plus 7 minus 2 minus 1, then that will be equals to plus 4 minus 2, okay, then plus 5 and minus 2. So we have assigned the oxidation number. So in step first we have to simply balance the other atoms except hydrogen and the oxygen atom and assign the oxidation number to that one. Now step number second. What about the step number 6? Find the atom that have changed oxidation number and by how much. Draw the bracket to connect the atom of the element that are oxidized. Similarly, draw the bracket connect to the atom of the element that are reduced. Now here just we can take the reference of our first step one, plus 7 to plus 4. So as there is decrease in the oxidation number, this will be our reduction reaction. Okay, and bromium minus 1 to plus 5. So there is increase in the oxidation number, is it right? So that will be the oxidation process. So in the step second we have to simply identify this one. Okay, so write down again the same equation, MnO4 minus aqueous plus Br minus aqueous gives MnO2 solid plus BrO3 minus aqueous. Okay, now here that is oxidation number plus 7 and here minus 1, here plus 4 and here plus 5. So we have to connect this oxidation process and the reduction process one. Plus 7 to plus 4, which is this process, and minus 1 to plus 5, which is this process. So obviously this will be your reduction process or reduction reaction, and this is your oxidation reaction one. Now let us find out what about the step number third one. Show an increase in oxidation number per atom of oxidized species and hence the net increase in oxidation number. Similarly, show a decrease in oxidation number per atom of a reduced species and the net decrease in the oxidation number. That is our step number third one. So we are assigning net increase and decrease in oxidation number, net increase and decrease in oxidation number. Okay, that's it. A. Okay, increase in oxidation number, bromine -1 to bromine +5. Okay, so what about the increase per atom? As we know that here only one bromine and only one bromine, therefore increase per atom will equals to net increase, and that will be equals to, that is +5 minus -1, which comes out as a +6. So this is the net increase. Okay, net increase in the oxidation number 1. Now similarly we will find out for net decrease in oxidation number. So decrease in oxidation number, that is manganese +7 to manganese +4, Okay, so let us find out the decrease per atom and net decrease. So decrease per atom, here decrease per atom will be equals to net decrease, as there is only one atom on both sides. So I will continue it as a net decrease, which is equals to +4 minus +7, which is equals to -3. Okay, so this is about your step number 3rd one. Okay, now let us go for the next step number 4th one. Okay, determine the factor that will make the total increase and decrease in oxidation number equal. Insert that coefficient into the equation 1. Fact number 4, we have to assign a coefficient, okay, or a factor, so that net increase will be equals to net decrease. So we know that if I multiply this particular equation by 2, okay, so net increase will be equals to net decrease. -3 into 2 will be the -6. So I will write it as an multiply net decrease by 2, okay, and insert this coefficient on both sides of a equation 1. We have to insert the two coefficient on your left and the right hand side. Now for which atom? For Mn atom. So our equation will be modified as a 2MnO4 minus aqueous plus Br minus aqueous gives 2MnO2 aqueous, solid, not aqueous, solid, plus PrO3 minus aqueous. So this is the two coefficient that we have insert one. Okay, so that is nothing but the two coefficient that we have decided here one. Now let us go for the next step. Step number 5 says balance the oxygen atom by adding H2O to the side containing less oxygen atom, 1 H2O for 1 oxygen atom. Similarly, balance the hydrogen atom by adding H plus, that is proton ion, to this side with the less hydrogen atom one. What about the step number 5th one? We know that in the step number 5th we balance the hydrogen and the oxygen atom. Now for oxygen atom, so in the previous lecture you have learned it, okay, 1 H2O for 1 oxygen atom. Now let us count the oxygen atom first of all, that is 2 into 4, that means 8, and 2 into 2 means 4, plus 3 7. So here on your left hand side there is a 8 oxygen atom, okay, 2 into 4 8, and 2 into 2 will be the 4 plus 3 7. So obviously here we are going to add the 1 H2O to the right hand side one and write down that equation, that is 2 MnO4 minus aqueous plus Br minus aqueous gives 2 MnO2 solid plus BrO3 minus aqueous plus 2O in liquid one. Okay, so this is about your oxygen atom. Now similarly we have to balance it for hydrogen atom. Now for hydrogen atom we know that how we can balance it, 1 H plus for 1 hydrogen atom. Now count the hydrogen atom from your left hand side and from your right hand side one. So here no hydrogen atom, so obviously it will be 0. Now for here, now on your right hand side there will be the 2 hydrogen atoms, so obviously we are going to add the 2 H plus ion on the left hand side, and 2 MnO4 minus aqueous plus Br minus aqueous plus 2H plus ions, so that I have added, okay, gives again the similar equation, 2 MnO2 solid plus BrO3 minus aqueous gives 1 H2O, you know, plus H2O liquid. Okay, now this reaction is balanced for your hydrogen atom and the oxygen atom one. Now let us go to the step number 6, which is a different for your basic medium. So this is the differentiating step, okay, so which is that step 1. Reaction occur in basic medium, then add OH minus ion equal to the number of H plus ion on both sides of the equation. The H plus ion and the OH minus ion appearing on both sides of the equation are combined to give H2O molecule. Okay, so your step number 6 is the additional step from your acidic medium one. So here it is very simple one, we have to add the OH minus ions one. Okay, and now how much OH ions we have to add? Whatever the H plus ion we have added, that much H plus OH minus ion we are going to add on both sides of the equation. So let us modify that equation again, that is 2 MnO4 minus aqueous plus Br minus aqueous plus 2H plus aqueous plus 2OH minus aqueous gives 2 MnO2 solid plus, okay, I will write here BrO3 minus aqueous plus H2O liquid plus 2OH minus. So I have added the 2OH minus on both sides of the equation. Then it says that whatever the 2H plus and 2OH minus will combine to form water molecule. So again we have to modify this equation, that is 2 MnO4 minus aqueous plus Br minus aqueous plus 2H plus 2O minus will give 2H2O liquid gives 2 MnO2 solid plus BrO3 minus aqueous plus H2O liquid plus 2 OH minus aqueous one. Okay, so as we know that there is a 2 H2 on your left hand side, 1 H2 on your right hand side, one will cancel it out. Okay, and again the equation will modified as an 2 MnO4 minus aqueous plus Br minus aqueous plus H2O liquid gives 2 MnO2 solid plus BrO3 minus aqueous plus 2 OH minus ion aqueous. So here this particular water molecule get cancel out one, and here only one H2O molecule. So now last step, so the step number 3. Now what it says, check balanced equation, make sure that the reaction is balanced with respect to both number of atoms of each element and the charges one. So check out the equation with respect to the atoms and the charges one. We know that we already balanced the oxygen atom, hydrogen atom, and here other atoms are also balanced one. So all atoms from your left hand side and the right hand sides are balanced one. Now let us consider about the charges one. Remember, 2 for on 1 MnO4 minus 1 minus charge, for 2 that will be the minus 2 charge, only one minus 1 charge, so minus 1. So on your left hand side, okay, minus 3 charge. Let us find out for this one. So here BrO3 minus will have a minus 1 charge, only one molecule, therefore only one ion, therefore minus 1 charge. And for the 2 OH minus ion, for 1 OH minus ion there is minus 1 charge, for 2 OH minus ion there will be minus 2 charge. Minus 1 minus 2 will be equals to minus 3, and this is also equals to minus 3. So this reaction is balanced with respect to all atoms and the charges one. So we have to write down this reaction as a final answer, that is 2 MnO4 minus aqueous plus Br minus aqueous plus H2O liquid gives 2 MnO2 solid plus BrO3 minus aqueous plus 2 OH minus ion. And you have to simply write down one statement: this reaction is balanced with respect to atoms and charges. This is the step that are involved for balancing your redox reaction with respect to atom and the charges one. So thanks for watching this video.